Alright, let's look at the homework 6.3, 6.4, problem number 10. Alright, so let's evaluate this improper integral. Alright, so remember that the first thing we should remember is if you want to find the antiderivative of e to the, say, ax plus b, right, then antiderivative is always the same exponential function but divided by the derivative of the power, in this case a plus c. Alright, so let's use that here. Alright, so first I'm going to rewrite this guy as integral from 0 to infinity. Then 5 is just a number, so I'll probably just put it in front. Right? So instead of writing 1 over e to the 2x, I'm going to write it as e to the negative 2x dx. Right? So the problem is having an infinitely long interval, so we're going to write it using limit. So this is going to be, right, 5 is just in front, just a number. Then you have a limit, right, as b approaches infinity, integral from 0 to b e to the negative 2x dx. Right? Then we can find the antiderivative. So this is going to be 5, and we still have a limit as b approaches positive infinity. Then antiderivative of e to the negative 2x would be e to the negative 2x over negative 2. And then this goes from 0 to b. Alright, so this is going to be, alright, so we have just negative 2 on the bottom. So I'll place it outside, it's just a constant. So it's going to be negative 5 halves, and the limit as b approaches infinity. And if you plug in b here, you have e to the negative 2b minus e to the 0, which is going to be 1. E to the 0 is 1, right? Alright, then we know that here, if b goes to infinity, e to the negative infinity is going to 0. So this guy is approaching 0. So therefore, we have negative 5 over 2 times negative 1. So it's going to be 5 halves is the value of this improper integral. Alright, that's it. I hope that this was clear.